Part 3 is calculate the percent increase or percent decrease. So this is another type of percent problem. So far we've learned 4. Recapping here, we have the 3 types from the table. So these 3 types here, and then at the end of this section we did one that was a little different. This one with Juanita and the game console wasn't one of those types. It's basically one of those types but backwards. And now the other 2 types are percent increase, percent decrease, but it's easy to know that those are what you're doing because they always have the words increase and decrease in them. So if you see those words increase or decrease in a percent problem, then you know that you are dealing with a percent increase or percent decrease. Now, this table here, you do not have to memorize this. It's easier just to think of it as find the change, like how did it change, and then divide by the original. So this all boils down to the change divided by the original. And it's not percent change, it's absolute change, so just subtraction. For example, with number 1, the enrollment at CCD increased from 5,200 students to 5,400 students over the last year. By what percent did the enrollment increase? It's increased because it went up. It wouldn't make sense to ask how much it decreased. So I want to subtract the 2 numbers. You can always subtract the smaller from the larger. And then I want to take that number and divide by the original. It originally started at 5,200 students. So if I divide that, I get 0.037, and that is 3.7%. So that was a 3.7% increase in enrollment. A value of a car dropped from 15,300 to 13,700 over the last year. What percent did it decrease? Again, it's a percent decrease problem because it went down. It wouldn't make sense to ask what the percent increase is. So 15,300 minus 13,700 is 1,600. I take that and divide by the original. It started at 15,300. So it went down had a typo there. Let me try that again. 0.1046, which is 10.46%. So the percent decrease of the value of a car went down by 10.46%. So both problems, all I did was subtract the 2 numbers and divide by the original. If you can remember that, you're going to be golden. Example 3, a flat tax of $1,000 was imposed on 2 businesses in a certain locality. One was a small business with annual profits of about $50,000, and the other was a national corporation with annual profits about $50 million. Discuss the percent decrease in profits each of these companies will suffer due to the newly imposed tax. So this isn't just subtract the 2 numbers and divide by the original, even though it does say percent decrease. So this is a percent decrease problem, but it's a little bit different. We want to know for both of them, so the subtraction part is sort of already done for us. This $1,000 is how much they went down. So both of them had to pay $1,000. So that means that the absolute decrease for both was $1,000. So the question is, how much of a percent decrease is that for the small business? Well, it would be 1,000 divided by its original, which is 50,000. And that comes out to be 0.02 or 2% decrease, which doesn't sound like a whole lot. But compared to the national corporation, so they're paying the same amount, $1,000, but it's over their original, which is $50 million. And that comes out to be, well, if you put it in your calculator, you might get this 2e to the negative 5 or something similar to that. What that means is, this is scientific notation, which we'll get into a little bit later, but it means that I need to move the decimal 5 places to the left. So 2 is here, my decimal's here, 1, 2, 3, 4, 5. So there's 4 zeros in front of the 2, or it's, let me see if I can scoot over. Oh, I ran out of room. 0 point. So if I move it 2 to the right to make it a percent, 0.002%. That is a big difference. Or no, not loss, decrease. Yeah, I'll use the same verbiage. So the big corporation only had 0.002% loss compared to a 2% loss. That is a huge amount. It's the small business is affected 1,000 times more than the national corporation by this. So I would say that the flat tax affects the small business much more than the corporation. And to make it more fair, it should be a percentage of their profits instead of a flat tax, because with the flat tax, the small business gets hurt by it much more than the big corporation. $1,000 for the big corporation is nothing, whereas $1,000 for a small business is quite a bit. So this comes into real life when, for example, you might have heard about Trump in the news and how he's only paid $1,000 in income taxes when people who make way, 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 way less money than him pay that or more. So it's very similar to the situation where maybe somebody's income is $50,000 and Trump's income is $50 million and he still only pays $1,000 in taxes. So that's where you might hear or see about this in the real world. The base of a percent is very important. So this is a homework problem that I always get questions on with company sales in Seattle compared to them in Portland. Expressive word comparison between two quantity. Okay, so depending on which quantity we use as a base, while both may be true statistics, often media outlets will choose to use the version that sounds more shocking or seems to be better to support their views. So you might hear, you can represent things in different ways, and the media will choose which one sounds more dramatic. So we're going to do an example with company sales in Seattle were $330,000 in 2012. While their sales in Portland were $230,000 for the same year. So we're going to find A, Seattle sales were blank percent larger than Portland's. B, Portland sales were blank percent smaller than Seattle's. And C, Portland sales were blank percent of Seattle. So those are all different values that you can find based off these two numbers. But they're found in very different ways. But one thing we're going to need for at least two of these questions is the subtraction. Subtract the two numbers. So 330,000 minus 230,000 comes out nicely. It's just 100,000. So the first one is Seattle sales were blank percent larger than Portland's. So it's basically a percent increase. So I want to take that $100,000, and it's then Portland. So I want to use Portland sales, which were 230,000. Divide the two numbers, and you get a decimal. I rounded to 4 places, and then turn it into a percent. 43.48%. So Seattle sales were 43.48% larger than Portland's. So that sounds like a decent amount. The next one, Portland sales were blank percent smaller than Seattle's. So we still use the 100,000 because we're talking about a percent decrease. But Seattle's were $330,000. Divide the numbers and you get 0.303030 repeating. So that comes out to be about 30.3%. That doesn't sound as dramatic. But this last one, we want the percent of Portland's sales compared to Seattle's. Or Portland sales were blank percent of Seattle's. So you just divide Portland sales by Seattle sales, which is 0.69. The 69 is repeating. So it comes out to be about 69.7%, which is probably the number that the media will use because it's the most dramatic one, even though all three of these things essentially are using, I mean, they're all three of them are using the same information. It's just different ways to talk about it.